Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISI Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses.
So it's a really easy problem, and it's a problem number 59. So let alpha be like it's given alpha is defined like this. Now observe, if you first thing when you're doing the limit, guys, observe always the first idea is always the format. What format it is, guys? Okay, is it infinity by infinity? Is it 1 to the power infinity? Is it 0 to the power infinity? What type of format? Because depending on the various formats, we solve in different ways. So let's see the format first. What is the type of this limit? So the type of the limit is the following, that okay, it's a bit I mean it's too much cluttered over here, but focus as my as I scroll through the solution. So if you observe that the limit is this format, so first check that where the what is the type. This is checking the type. Okay, if you check the type, you observe that 1 by n square goes to 0, so 3 by n square also goes to 0. Okay, and if 3 by n square goes to 0, then sine 3 by n square by 3 by n square will go to 1, because sine x by x goes to 1 as x tends to 0. Okay, it's a subsequence of that function. So therefore that really helps us in understanding that n times sine 3 by n square will behave like 3 by n, okay, which will go to 0. Okay, that's the basic idea. So this term will go to 0, and you can easily understand this term is going to infinity. Very good, perfect. Now given this knowledge, when you have, therefore it's of the form what? It's of the form 1 to the power infinity format, guys. Okay, that is the format. Now observe it very carefully, that what we can use, you cannot use L'Hopital rule directly in sequence. Okay, because L'Hopital rule has a different aspect to it. Also there's a result. Okay, you prove using L'Hopital rule that so this is a basic idea, this is a core idea, that instead of taking the sequence, you take f of that sequence. Okay, f of n, and you know that f of x is going to that limit. If you can prove f of x going to that limit, then a subsequence of this, because if a function goes to a certain limit, all the sequences that can be created out of that function also go to the same limit if x goes to infinity. Okay, so similarly, if you observe over here that we will try to do it in terms of the function, because we have the results in terms of the function only. So let's observe this, that if you take the result, this is a very important result that can really help you out, that limit fx is this, that its limit x tends to infinity 1 plus gx whole to the power hx, where gx is going towards 0 and hx is going towards infinity. Okay, understand this very carefully. I'm just explaining to you once again. So 1 plus gx whole to the power hx, okay, this goes towards 0, this goes towards infinity. By the exponential, the exponential property, the limit of the exponential 1 plus gx, I'm giving you the proof idea, whole to the power 1 by gx, this will go to the e, okay, since gx is going towards 0. And therefore, to adjust with it, observe this is nothing but 1 plus 1 by 1 plus gx whole to the power 1 by gx, uska whole to the power gx times hx. Now this gx is cancelling this out. So therefore, observe that this turns out to be limit e to the power limit x tends to infinity hx into gx. Okay, this only can happen if you have these two conditions over here. And if you put this value over here, hx and gx value correspondingly, you have 2x squared sine 3 by x squared, and use the same idea over here that I've used here, so that sine 3 by x squared by 3 by x squared will go to 1. So the corresponding adjusting factor is 6. So therefore, this limit will be 6. That means this will be e to the power 6. So you need to find log of this limit. That is, it will turn out to be 6. So this is the basic idea, guys. I hope you enjoyed the problem solving out here. So we solved 4 problems. You saw the first one was on Taylor series. The next one was based on monotone convergence theorem and basics of the sequences. The next one is Sandridge theorem, and this one finally is using that interesting the idea of how to move towards a function and using that 1 to the power infinity format of solutions, guys.
To book a trial class for your preparation courses of IIT GEM MS, ISIM STAT and CMI MS Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.